All right, take a moment to try the odds as your bell ringer. Okay, when we do this one, remember the base of the exponent is your radicand now, and the bottom of the fraction is the root, just like the root's on the bottom of a tree. So we'd be taking the square root, and then our top of our exponent, our numerator, is an exponent on top here. We don't necessarily need to put that 1 here because an exponent of 1 doesn't change our answer. So we'd be taking the square root of 36, which is just 6. For 85, our radicand is 8. Our root is on the bottom of that fraction. So we're taking the cube root of 8 to the first, which is just equal to 2. 2 times itself, 3 times is 8. For 87, our radicand is 125. We are taking the cube root of that, because that's the bottom of our fraction, and then we are squaring that. Remember, that square can either go at the top inside our radical or outside like I have. It is best to put that 2 as the exponent outside of our radical. Because I can now take the cube root of 125 easily, because that would be 5. 5 times 5 times 5 is 125. And I can square 5 and get 25. If you had the exponent on the inside, you'd have to do 125 squared first, which is much more difficult, and then take the cube root of that, which again is difficult. So I'll put the 32 in the denominator, and then when I put that 32 in the denominator, I get a positive 4/5. And now I can write this in radical form. 32 is my radicand. I'm now taking the 5th root, and the 4 would be the exponent. Again, much easier to put the 4 outside of the exponent because I can take the 5th root of 32. 1 times itself, 5 times is 32. 2. And then I can do 2 to the 4th, which is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1/16 would be our answer to that one. Right, any questions on that? Kind of recaps what we did yesterday. All right, and then the last section we have here, we have some quick review here. All right, so if I have x to the third times x to the second, remember, what do I do with those exponents? I add them, so I get x to the 5th. So if I now have x to, say, the 2/3 times x to the 1/2, again, what am I doing with those exponents? I'm still adding them. It's just I'm going to have to add fractions now. So I'm going to add 2/3 plus 1/2. So in order to add fractions, what do you have to have in order to add fractions? Equal denominators. So that common multiple of 3 and 2 would be 6. So I'm going to multiply top and bottom of this first fraction by 2 over 2. That would make the bottom of the first fraction 6, and I want to multiply second fraction top and bottom by 3. So that gives me 4/6 plus 3/6, which would be, how do you add those fractions then once you have the common denominator? 7/6. Add the tops, keep the bottom the same, so 7/6. So this would be x to the 7/6. So again, same exact rule we've always been working with. It's just now, if we have a fraction in the exponent, we just have to remember how to add fractions. Similarly with x to the second to the third, what am I doing with those exponents? Multiply them, so x to the 6th. However, if I have x to the 1/2 times, x to the 1/2 to the 1/3. Now I just have to remember how to multiply fractions. So now I'm doing 1/2 times 1/3. And how do you multiply fractions?
Cross.
There's an equal sign, you cross multiply. You're multiplying, you multiply straight across. 1 times 1 is 1. 2 times 3 is 6. So this would be x to the 1/6. Okay, so that's really just the last part of what we have to do today, is kind of applying these law of exponent problems when we have fractional exponents. So again, a quick reminder on how you multiply fractions. 2/5 times 3/4. Multiply straight across, right? So 2 times 3 is 6. 2 times 4 is 20. We do want to reduce that. 2 goes into 6 3 times. 2 goes into 20 10 times. You could also, if you wanted to, remember when you're multiplying, you said cross multiply. You can cross reduce. So cross reduce is where I say, look diagonally. There's nothing that divides into 3 and 5, but 2 and 4. 2 goes into 2 1 time. 2 goes into 4 2 times, and then I could do 1/3. 1 times 3 is 3. 5 times 2 is 10, and then it's already reduced. So you can cross reduce if you want to. As we said before, if you're adding fractions, you need a common denominator. This one already has the common denominator, so you just add the tops, keep the bottom the same. And then for the bottom here, 2/5 plus 3/4, we need that common denominator. In this case, what's the first common multiple of 5 and 4? Common multiple. 5, 10, 15, 20, 25, 30, 4, 8, what's that? 20. So I have to multiply top and bottom of the first fraction by what to get me to 20? 4 over 4. Second fraction, top and bottom by 5 over 5. And that would give us 8/20 plus 15/20, which would be 23/20. Okay, so just remember those things. All right, so go ahead and write those two problems down. All right, so remember, this is really 2 times x to the 4/3 times 5 times x to the 8/3. You don't really need that parentheses. So I'm multiplying the coefficients together. 2 times 5 is 10. I have my like bases of x, and what do I have to do with my exponents in this case? We're adding them. So I'm adding 4/3 plus 8/3. In this case, we already have our common denominator. 4 plus 8 is 12. 12/3. 12/3 is just equal to 4. We get 10x to the 4th for that one. For B, we're dividing now. So again, I can separate this as my regular numbers. 20 divided by 5 is 4. And then I'm doing x to the fourth divided by x to the 3 halves. Again, if I'm dividing like bases, what do I do with those exponents? Subtract them. So I'm doing 4 minus 3 halves. Remember, what's really underneath this 4? A 1. So I need to make this a 2, so I can multiply top and bottom by 2. We get 8 halves minus 3 halves, which would give us Elliot, what would it give us?
Give us
5 over 2, yes. So 4 to the 5 halves. We could, oops, we need an x here. 4x to the 5 halves, because that 5 halves is the exponent on the x. Okay, so 4x to the 5 halves would be our answer for that one. Okay, so as you see, again, not really any different, it's just the math is a little harder because we're having fractions. All right, so take a moment and try those two in your groups. All right, so what do I have to do with the 3 and the 4 here? Multiply them. So you should get 12 as your regular number. What do we have to do with the 2/3 and the 3/4? Got to add them. Again, we need a common denominator, so what do I have to multiply top and bottom of the first fraction by? 4. Multiply top and bottom of the second fraction by. So we get 8/12 plus 9/12, which would be 17/12. And that can't be reduced. So that should be your answer. 12x to the 17/12. For the second one, before we actually do the division, what's the first thing we actually have to do? Think of PEMDAS. Right, we got to get those exponents taken care of. So remember, there's really an exponent of 1 on that 2. So on the top, I'm going to have 2 to the 4th, and then I'm multiplying 1/5 times 4 over 1, which would be 4/5. 2 to the 4th, 2 times 2 is 8, 2 times 2 is 4, times 2 is 8, times 2 is 16. So your top should be 16y to the 4/5. That's the first step. And then you have y to the 3/10. So I'm doing 16 divided by 1, which is just 16 on the top of the fraction. And what am I doing with 4/5 and 3/10? Subtracting. So 4/5 minus 3/10. I'm going to multiply top and bottom of the first fraction by what?
2 over 2.
2 over 2. I don't have to touch my second fraction. So that would be 5/10. 5/10 reduces to 1/2. So this would be 16y to the 1/2 power. Questions on that at all? All right, I'm going to give you some time right now to work on the review. Tomorrow we'll practice a little bit more with these rational problems where we have fractional exponents. So the review is up on the side board. It's also in Google Classroom. I did post an answer key in Google Classroom. Okay, I'm not collecting the review. It is there for you to study and prepare for the quiz. I gave you the entire answer key so you can check all of your work, all work that's there that you can use as needed. Right?